The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Ben, I was watching a video about the new Nintendo console.
Oh yeah, the Switch.
So I thought it was interesting because our fans are always asking us to take a console and portabilize it, or take a portable and consoleize it.
Right.
And this system's kind of both. It's a console and a portable together.
Yeah, it's a very interesting concept. We'll have to see if it works out in the long run. But Nintendo's done a lot of interesting consoles over the years.
Yeah.
They do take chances, like you can't fault them for that. In fact, they were way ahead of the VR craze back in 1995 when they released the Virtual Boy.
Yeah, that super awkward headset that you had to like crouch down and like stick your face into and then see your chiropractor after you were done playing after a few hours.
Apparently the focus group said people want video games to be like a trip to the eye doctor, and Nintendo listened. Well, it was kind of a huge flop, but it's an interesting footnote in gaming history. So I thought it'd be cool to obtain a Virtual Boy and then do a teardown, take it apart, see what's inside, and how it worked.
Ooh, that sounds like a good plan. Hey, what could we do with it after we tear it down?
Well, you know, it's never as much fun putting something back together as it is taking it apart.
That's true.
So I was thinking we could improve it.
Okay.
We could try to make it smaller, more compact, fit on your head, have the headphones built in, make it more like, you know, a modern Vive, Rift, PlayStation VR. So yeah, we could basically make like a virtual man.
Ah, see what you did there.
All right, so in this episode, we're gonna do the teardown, and then the next episode, we're going to improve it. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I wanna live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, here is the Nintendo Virtual Boy. Let's take a look at its features. There's a knob here for changing the distance between your eyes, just like the Oculus Rift. Focus, so that probably brings the lens forward and back. You look through it here. Oh, Virtual Boy. I remember when this came out. On the bottom, we have the controller connector, and the controller is where the batteries are as well. Wonder if there's anything else on the controller. I guess we'll find out. Cartridge goes in here. Mario Tennis. I'm gonna play tennis. Oh, you could hook up two Virtual Boys, maybe with this connector, as if anyone else that you knew would even have one. Over here, headphones. I don't know if it has sound built in or not. Maybe it does. And volume. All right. I guess the idea was, instead of like strapping this to your head, you would set it on a table and then play. It has a weird smell to it too. It smells like fail, the new cologne. Failure. Let's see if it works. Switching it on. Oh, it does have speakers right here. And it's in stereo. Oh, this is quite the song. Read instructions before use or you may die. That's an issue I have with all the virtual helmets they make these days. It's like, oh, glasses wearers, who cares about them? It looks like one of the displays is completely out. Well, that would probably be part of the problem. Well, there's only one way to fix that. We've got to take it apart. Look at this weird stand. Why would anyone want this? Well, it looks like we have the world famous Nintendo security screws here. Oh no, and it's got them here and here too. Oh, I hate these screws. I don't have a screwdriver for it. I guess I'm gonna have to rig something up. I had to Dremel one of my old screwdrivers to make a notched end, but I got all the Nintendo security screws out. Let's crack this puppy open. Well, we don't really have to crack it open because, you know, this was made in a time 20 years ago when they still used screws. Big chip labeled View VPU, Video Processing Unit. Right next to it, VRM View, that's probably Video RAM. Not sure what that one does. Oh, it looks like there's one of these per eye. So this must do all the video processing. See, we have this going to the eyepiece. That's weird. It's a weird package standing up on end like that. So I've heard that the issue with these is that the ribbon cables come loose. I wonder if that's why it doesn't show up on one of them. It won't seem loose. My understanding is the way this system works is there's a bunch of LEDs, one row of LEDs, and then there's a rotating mirror which reflects that up and down to create a raster pattern on the screen. And there's 2 of those, of course. Let's see if it'll fire up in this state. Let's see, the cartridge went like this, I think. You, sir, no one can be here. Oh, what great music. Oh, wow, look at that. That's a large amount of movement for the eye distance. Look at that. Well, at least they were thinking. Oh, that's why they have the ribbon cable, see, so it can flex and change, see? Yeah, the image on the left is still, the one on the right's fine. The one on the left is the one that's messed up. I mean, I can at least see it now, but, well, when in doubt, jiggle the cable. I think the problem is on this end of the cable. Like when I touch it, I see things change. The other end doesn't seem to have any effect. Oh, these are speakers. Great. All right, let's dig a little deeper. Oh no, more security screws. Well, actually, once you get inside of a unit like this, they just stop putting security screws in. They're like, well, you're already inside, who cares now? So I wonder if this is the CPU and the VPU, or if there's a separate CPU. Ooh, what? Oh, what the heck is, that is bizarre. Oh, that is weird. I can't say I've seen one like that inside of a game console before. This one's a little different though. This one looks normal, I hope. Wow, I can't wait to be hunched over my Virtual Boy all day. Well, there's more RAM on this side. It's different though. Okay, so this is 8K of RAM, and this is 4K. You can tell because this one ends with a 64, so that means 64 kilobits, which divided by 8 is 8 kilobytes. And this one's 4 kilobytes. It's not a whole heck of a lot. I wonder what it's for. Like, what did the Game Boy have? The Game Boy had like 8K RAM, 8K video RAM. Like the Game Boy, even though it's black and white, actually had a lot more RAM than the Nintendo did. I'm gonna win Wimbledon. Oh no, I didn't win. Oh, well, obviously we have to take these lenses out and see what it looks like. Bye-bye lenses. Yeah, see that? See how they move a little bit? I bet these oscillate based off, well, there's a coil back here. So I'm guessing as these oscillate based off electromagnetic frequency, and they synchronize that with the thing that draws the line, and that creates an image. Like on an old CRT television, there's an electron beam, it goes and draws the image. But with this, there's like one line of image, and then there's a mirror, and by rotating, it makes the image fill the screen. All right, let's remove more things, because it looks like we're gonna have to take this whole assembly out in one piece on that metal frame. So another money-making scheme, go back in time to 1996 when these were on clearance for $25. Buy them all, then come back to the future, because on eBay, they fetch a pretty penny, and then buy Apple stock while you're there. See, my plan, if I had a time machine, is I would buy a whole bunch of like cheap $20 DVD players, and then I would put them in my time machine, go back to like 1998, when DVD players were $600, sell all of mine for like $200, and then I would take that money and use it to buy Apple stock in 1998. Oh, okay, so we got the audio amplifier here, audio amplifier circuit, then we have the sound coming in from the main board here, left and right output, headphone jack, volume control. All right, so we can actually probably set that aside as its own thing. Well, it looks like it's got a grounding clip. I'll just remove that. Virtual Boy audio amplifier. I like old electronics. Everything was, you know, compartmentalized. It's like, oh, this is clearly the audio amplifier. Now an audio amplifier would be like the size of, you know, a grain of rice. So this is the power adapter, controller, and link port. It also has a grounding clip on this frame. Remove that. Chew over here. So this is where the magic happens, as they would say. Wow, look at all this stuff. Oh, this is very, very mechanical. Okay, so this allows you to change the position of the lenses based off the distance of your eyes. It's actually a pretty generous amount of movement. Look at that. Oh, look at that. That is weird. Look at this. So the focus, you slide the knob back and forth, but it has a 45-degree slit in it. So on the system itself, the focus is actually back and forth. See that? Holy mackerel, Batman. See if we can get this LED element off the end. I go out too many days. Oh, there it is. Here's the LED element itself. So this draws one line of LEDs, and it's reflected through a lens, and this mirror rotates to create an image. So So basically it takes this and goes, and it fills out an image in your brain. It'd be cool to turn it on and watch the mirrors. They'd probably move so fast you wouldn't even really see them moving, kind of like a hummingbird. I'm like a hummingbird, I only fly away. Nelly Furtado reference. Okay, so this is what the LEDs see. See how the image moves when I move the mirror? So yeah, that's how it creates an image. It would actually probably go like this. It would draw one line, and then as it sweeps back, it would draw the other line. So it would go like whoosh, 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 whoosh. Oh yeah, what's back here? There's more chips. This probably works in tandem with the main board that we found to actually drive everything. So now that we found all the chips, I think we can safely say this is a CPU and a video processor. And then we have probably video RAM and work RAM here. Although that's weird, 4K work RAM would actually be less than what the Game Boy had, which seems a little weird. So this eyepiece is working, it's the left one that's not. So I guess what happens is this ribbon cable here delaminates and stops working, and that's when you get a fuzzy image. So before we try to modify this system, I think we should get it working by fixing this ribbon cable. I used my heat gun to heat up the edges of the ribbon cable, the flat flex cable, where it connects to the LED circuit board. I guess this can come loose over time, and it appears like it's like glued in place or something. So what I did was I heated it up, and then I used a squeegee while it was still quite warm to press everything down to make sure there's a good contact. Let's take a look and see if it worked. Watch the mirrors spin up. See them start to rotate? Pretty cool, huh? Let's see if we have something on both screens now. Actually, I can still see a few glitches on the right-hand side. It's a lot better than it was. I can probably just heat it up again. Oh yeah, if I touch it with my thumb, they go away. I could probably just glue some sort of pad or piece of plastic on here to apply constant force, just to make sure it stays put. So they couldn't have made this color in 1995 because blue LEDs did not yet exist. They're about 5 years away, and probably would have been about 10 years away from being small enough. All right, let's make a new folder. Virtual Boy. Okay, it's 1.02 inches. We just need the top of it. As far as the height's concerned, we know this distance. We also need this distance because I want to put a clip. So it'll clip behind this board. It'll go over here, have tension in that direction, and then be held in place by this screw. Or I guess we could also hold it in place with this screw. No, this one's actually better because see how it's a straighter shot across? And then we can put some foam here, and that'll apply constant pressure to it. So we're also going to need to know a few more things, such as the thickness of the board, which is 0.048. So I'll probably just call it, well, with error, I'll call it 0.055. So here on the screen, we're going to go 0.1 over, which is the X distance. And then when we look at it in 3D, we're going to go down 0.055, which is the thickness of the circuit board. Although we should actually go a little bit further than that because we have to clip around it too. Let's come in just a little bit. We'll come in like 0.03. So we actually will do it like this. So we'll draw another square here, 0.03. Okay, so we want to think about how thick that is. So we have 0.055 for the circuit board. How much depth do we have? Past the edge of the circuit board, the amount of depth we have is, drum roll, 0.057. So I think I'll do 0.04. So the total there would be the thickness of the circuit board plus, I don't know why I'm using a calculator for that, 0.95. So we go negative 0.095. Okay. Now we bring the sketch back, and we just take this and we do the negative thickness of the circuit board. Well, maybe with a little bit of gap, so 0.06. So that's the clip right there that'll go around the back of the circuit board and hold it in place. So the circuit board fits here. I'm going to round off these actually just to give it a little bit more wiggle room. So we have to take into account the fact that the circuit board here is flush with the top of the plastic. If we just make our plastic piece go up to the top, it's going to intersect with this, so we have to measure what this is, which is 0.0, well, to be safe, I'll say 0.06. So in our drawing, we have to actually remove that from the lower clip. We can still go over it, but we can't have it under it. So I'm going to take this, connect here, go down 0.06, which is actually quite a bit. All right, so that part of it's going to actually get erased. There we go. All right, let's go back to the main portion here. So this is on the top of the circuit board. But we have to take into account whatever we're using to compress it. In this case, funky foam. So I'm going to get a piece of funky foam. Okay, funky foam uncompressed is 0.075 inches thick. We want the compressed version, so I'm going to squish it with my caliper. Let's say 0.05. So we need to have the thickness of the funky foam and also the thickness of the outer wall. Then we can add those together and then do a subtraction. I think we have a decent amount of space off the back of this. 0.0, let's go 0.04 to that. So we'll do this. We'll take the back of it, I probably want to make 0.80 at least. Let's get our calculator back. 0.04 up plus the rear thickness is 0.12. So we're going to take all this stuff here and go 0.12 up, like that. We're going to flip it around. This is where the circuit board is. So now we're actually going to come up 0.04, and that's where the funky foam will go. So the sketch layer, which is the transparent looking one, that represents the surface of the circuit board, and this gap here is where the funky foam will fit in. But we still need one more thing, and that is how this interfaces with the screw on the end. So we came up a certain amount here to be flush with the screw. So 0.04 inches off of the circuit board is the surface of the screw mount. Let's also get a distance to the screw here. Distance to center, almost exactly 0.2 inches. How tall is this? 0.2, right? 0.2 over and 0.15 down. Now we'll measure the opening here. We'll give it a huge margin of error. I'll give it like 0.15. So even if we're a little off, the screw will still fit. So we'll do the same thing with this. We're going to go 0.12, which we're bringing up there, and then down here we'll remove some of it. Okay, so this is my idea for the clip clamp. And luckily, these two LED emitters they're not symmetrical, they're actually the same thing, so one of these clamps will work for both of them. I don't have to flip the image or anything. All right, so I'll get these 3D printed, and then we'll see if they work. Okay, here's the clamps that I printed. A few Dremel adjustments. They're kind of small. Hopefully they work. Here's the idea. Clamps on here, then pulls against the funky foam, applying constant pressure to the contacts. The question is there enough room to fit this piece in? That I don't know. Well, it seems like it fits. Yeah, these things, they were on clearance like not even a year after they were released. It was pretty bad. No one will pay for it, which makes it priceless. And Mario was like, I lost all of my money. Okay, I reheated the flat flex ribbon cable, pushed it back down with a squeegee, and then I 3D printed a clamp that goes over it along with some funky foam to hold the ribbon cable in place. And now the image is perfect, except for the fact it's still a Virtual Boy. But you know, what are you gonna do? Mario! See, I really can't forgive Mario for making a movie about himself and his brother. All right, well, it looks like that fix worked. So I guess the question now is, what could we do with the Virtual Boy? All right, so now that we know that it works and we fixed the ribbon cables, let's dive a little deeper into the unit. I am Diopter Man. So when he was a kid, people made fun of his diopter. Yeah, that sounds like something kids would pick on people for.
Yeah, sure does.
Pretty realistic. My dad's an optometrist, and he told me that you're weird. I don't care what they say about you. I believe in you. Thanks, random woman. A romantic scene occurs. Oh, and then the girl from the flashback shows up, and she makes him change his mind. It's too late for me now. What are you doing? Learning. All right, I slid this one over. Now I think we should be able to get this one to come out, maybe. Oh, there's a grounding strap in place. Other than that, yes, I think it's loose. Diopter collapse. And of course, his diopter is only like 1/10% off or something. Somehow people can identify it. This is what makes the whole thing go. I was cast out from my home, left to die. Check out in there, there's an opto-isolator, so the system can tell what's going on. That must be how it keeps sync. Well, that makes sense. Yeah, we can obviously make this smaller, better, more Italian. So I became Dioptoclops. Do you not remember me, high school bully? I don't know who you are. I will remove the other thing and then we'll figure out what to do. So here are the units. They had focus levers tied together. So the lever actually goes forward and back and this chamber rotates it. So what I'm gonna do is I'm gonna bring this chamber all the way in that direction. Well, it's not really a chamber, it's more of a rotating cam. Now I'm gonna pop it off. Dioptoclops, raised by trees. They had no eyes, so they did not judge me. I would build a machine. I don't know how I learned how to build it since I was raised by trees. That would send a gas throughout the city, turning everyone into freaks like me. Overview of the parts. Here are the two LED emitter and vibrating mirror assemblies that create the stereoscopic images. This is a driver board for the mirror assembly. Got our two filters, which we don't really need. They kind of make the image dimmer as well. Virtual Boy cartridge. I guess they only made like, what, 15 games for this system? This is the main board. It's got all the RAM, the GPU, CPU here, the dual connectors for the screens, and other connectors such as power controller, and this looks like some sort of power regulator here. Then we had the slider assembly, which was pretty cool. This allowed you to change the diopter setting, the distance between eyes, and also the focus. And this tray was used to mount the main board. So there you go, all of the parts inside of a Virtual Boy, a video game console system thing ahead of its time. Well, that's all the time we have for today. We took apart the Virtual Boy, and in our next episode, we're going to try to improve the Virtual Boy, take the existing guts, and make a better headset out of it.
We've shown you what 90s VR technology was capable of, and we've seen what today's VR technology is capable of. What features would you like to see in future VR technology? Let us know in the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you later. Goggles, right? Get it? It's me, Mario. I'm done being a doctor. I'm gonna play tennis. Let's kick some ice. I got nothing in my brain. Beep, 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 beep. It turned out I didn't have a doctor's license. And I killed all of my patients with spaghetti. Snake, there are nanoparticles in your arm. Nanoparticles. The hunchback in the bell tower has turned on the infinity beam. Soon all of Paris will become hunchbacks like him. Ha ha ha! Once everyone is a hunchback like me, then I can find a date. Soon everyone in the city shall have the same diopter setting as I do. Yes. You've become worse than those who tormented you originally. Search your heart, Dioptoclops. You know it be true. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.